Okay, girls, well, this is an extension of the Locus 2-unit topic. It's the 3-unit topic called Parametric Equations. And when we do this, we've got to think of, you know how equations are, you know how we've got y equals x squared is like your normal type of equation. Remember that's the x squared is 4ay type? So pretty much with parametrics, the only type of equation you will do is the x squared is 4ay type with parametrics, okay? You won't do the y squared is 4ax, or rarely ever. It's pretty much focused on the x squared is 4ay type of parabola. So, as been stated earlier, the locus of a point P which moves so that it's equidistant from a fixed point, which is the focus, remember that? And the fixed line, the directrix, is the parabola. X squared equals 4ay. This equation, when you've got equations with both x's and y's in them, you know how we've got x squared is 4ay, it's called a Cartesian equation, the Cartesian equation of the parabola. But we're going to learn how to write the parametric equation of the parabola. So, Cartesian equation is x squared is 4ay. But what we're going to do, we're going to introduce a third, another parameter. So we've got a third variable called a parameter. You know how x and y, they're called variables. But we're now going to introduce a third variable called t, okay? So sometimes it's more convenient to express the equation of the curve by means of two equations involving a third parameter or third variable called the parameter. Now what we're going to do, you just have to know this off by heart. The parameters will be x equals 2at and y equals at squared. That's what the parameters will be. So all you've got to know is for the parabola x squared equals 4ay, that the general parameters are going to be x equals 2at and y equals at squared. So it's just a third variable. So you know how your equation is x squared is 4ay, it's made up of the variables x and y. We're now introducing a third variable, and that third variable is called a parameter. And that third variable is going to be given the letter t, and it's called a parameter. All right? So the parameter is t, and because we're now going to write this equation x squared equals 4ay in terms of t, instead of in terms of this just x squared and y, it's when we write it in terms of t, it's called a parametric equation because it's written with that third parameter. Look, once I start doing examples, you'll get it, all right? Now, so for example, always with this type of parabola, x equals 2at is how, so what we're going to do, instead of having x squared is 4ay, we're going to have a point on the parabola, and the x value is 2at, and the y value is at squared. So any point on the parabola can be 2at, at squared. It can be written in that format. Now, if I say let x equals 2at, and I substitute it into x squared is 4ay, now that's what they're doing here. So if I let x equals 2at, and I substitute it into x squared is 4ay, what do I get? 2at squared is 4ay. I'm just doing what they've got there. Can you see? 4a squared t squared is 4ay. Now, girls, can you see that or not really? Now, comparing them, so I've got here 4a squared t squared is 4ay. Girls, can you make y the subject? If I make y the subject, don't I go 4a squared t squared over 4a? Right, that's a bit messy. If I make y the subject, I get 4a squared t squared over 4a. Do you agree? Get that? So what I did, we substituted x is 2at into the original equation, x squared is 4ay. We got 2at all squared is 4ay. In other words, 4a squared t squared is 4ay. Now if we make y the subject by dividing by 4a, we get the a's cancel and the 4's cancel, and you get y is what? At squared. So anyway, you just need to know x is 2at, y is at squared. Okay? So girls, in this box, this is what you need to know.
Now you're off.
All right. It doesn't matter. Okay, so basically this is what you need to know. Cartesian equation is your normal equation with x's and y's, and your parametric equations give you the x coordinate and the y coordinate in terms of another parameter t. So your parametric equations are x is 2at, y is at squared. Okay? Where the domain is, in other words, where t is the set of all real numbers. Okay? Don't worry about that yet. All right, now what we'll do... I don't know. Probably not. Okay. Okay, now, in other words, this is what you've got, girls. You've got a parabola. You might want to draw this down here. It's the parabola x squared is 4ay, but any point on the parabola can be written in terms of what? 2at, comma, at squared. That's the parameter. And if I substitute x is 2at into that x of the equation, I do get that y is at squared. You okay with this so far? All right. Now, if you look at this example 1 down here, x is 2t, y is t squared, and you know it's supposed to be x is 2at, y is at squared, just by looking at it, can you tell me what the parabola is? All right. You know how x is 2at? But this is not. And y is at squared, but you've got x is 2t. Doesn't the 2 equal 2a? What does a equal in this? So the parabola is just x squared is, you know how x squared is 4ay? What's the parabola? X squared is 4y. Anyway, look, we're going to do more of this. I'm just seeing if you can see that. But you don't have to do it that way. What you do here is, we've got x is 2t. So here we've got a table. We're just going to sketch each parameter, and by sketching each of these, you're really plotting the x point and the y point. So if you're told that x is 2t, just watch. When t is -3, isn't x negative 2 times -3 is -6? Do you get this? So girls, I've got t here. This is my x and my y value. When t is -3, x is 2 times -3 is -6. Can you see that? When t is -2, 2 times -2, the x value is -4. Can you see what's happening here? When t is -1, 2 times -1 is -2. When t is -1/2, 2 times -1/2 is -1. When t is 0, x is 0. Can you see what's happening here? Yeah? Now, this is the formula for y. So you've been given this parametric equation, x is 2t, y is t squared. You could, if you want, substitute different values of t into that, like what they've done here, and they're ending up with x, y values, but you don't normally do it like this. This is just for demonstration purposes to show you what this really means, but we're not going to do it like this ever again. It's just as an introduction to the topic, okay? We know that y is t squared. That's what they've told us. So when t is -3, y is 9. -3 squared is 9. When t is -2, y is 4. Do you get that? So you just keep continuing with that. And each x, y value, isn't it a point on the graph? So this is the point -6, 9. That's the point -4, 4, because it's an x and a y value. And so what they've done over the page is that they've sketched all those points. I'm just going to pick out a few points. I've got 0, 0 there. This might be the point 2, 1. That's the point 4, 4, etc. Do you see that? So that's been sketched up here, just noticing some of the points. You'll need to look at your sheet. When t's, so, you know, when t was 1, we got the point 2, 1. Did you see that? When t was 2, we got the point 4, 4. When t was 3, we got the point 6, 9. Now, you don't have to do it this way. You know what I could have just done? This is what I could have just done here. You know how we know that x is 2t, y is t squared? You don't have to do that table. You'll never do it again. What you would do is x is 2t, y is t squared. Make t the subject of this first one. So what's t? X on 2 and sub into y. Does that make sense? So you're given the two parameters, x is 2t, y is t squared. Make t the subject. So this is the parametric equation. If you want to write the Cartesian equation, Cartesian equations don't have t in them, you would make t the subject of this first one. So these are the parametric equations. My question might be, given these parametric equations, x equals 2t and y equals t squared, write the Cartesian equation. So Cartesian equation does not include t's. It's only got x's and y's. The Cartesian equation is what you've always seen in terms of y and x. So what we do, if you want to write the Cartesian equation, you eliminate the t, right? You get rid of the t. So make t the subject of this. So t is x on 2 and substitute it into y equals t squared. What will you get? Y is x on 2 squared. Y is x squared on 4. Cross multiplying. Yeah. 4y is x squared. Or, see, I'm just going, instead of divide by 4, I'm timesing by 4. Girls, can you see that's your x squared is 4ay, where a is what? 1. So it's parabola, vertex. So you'll know this. So if you look at that, you'll say, yep, I know that. It's the x squared is 4ay type. A is 1. Got it? Concave up with parameters, parametric equations, you've always got the x squared is 4ay type. You're only going to be doing that one type. Okay, concave up. The focal length is 1. The focus, you know, if it's this x squared is 4ay type, it's like this. A is 1. So isn't the focus going to be 0, 1? The vertex is 0, 0. Do you know where the directrix is? Yeah. Y is -1. Okay? So that's what we're just practicing today. You'll be given the 2 parametric equations and you've got to form the Cartesian. Just make t the subject and substitute in. Okay, let's look at another one. Okay. All right, we okay with that, girls? Do you get, so the parametric equations will be x is 2at, y equals at squared in that format, okay? Just have a look at, what's D? All right, we've done that. We ready? Sorry, maybe I should have written stuff out rather than look at this booklet. All right, let's look at the next bit. Okay, example 2 down here. It says, this is your normal type of parabola. If you're given this type, you'll be happy. And pretty much we just do that type anyway. So notice x equals 2at, y equals at squared. They're the parametric equations of the parabola. Find the Cartesian equation. So let's just practice. It's all down here. X is 2at. So how do you do part A? You've got x is 2at, y equals at squared. What do you think you do? Make t the subject of the first one. So it's done down here. So we make t the subject and then we substitute it into equation 2. Are we okay? So you write x is 2at equation 1, y equals at squared equation 2. Rewrite equation 1 as t is x on 2a. Are we okay? We'll substitute it into that and go over the page. You right? Okay. We'll do some on our own in a minute. You okay? I should do this on paper. You know how we had y equals at squared and we're substituting in t is x on 2a, so we're putting it in here. Y is a, x on 2a squared. Are we okay with that? So you get, when you square this, you get x squared over 4a squared. So you end up with a, x squared, 2 squared is 4, a squared is a squared. Can you see that? Yes. Now, you cancel what's the same from the numerator and the denominator. 1a from the top will cancel with 1 from the bottom, and you've got that y is x squared on 4a. And cross multiplying, or instead of opposite of divide by 4a is to times by 4a, and you'll get that 4ay is x squared from that. So x squared is 4ay is the Cartesian equation. Now, you remember from doing the parabola, x squared is 4ay, isn't the focal length a? Yeah. And the focus is 0a, because it's this. If you've got x squared is 4ay, I'll go bigger. I might just do some proper examples. I don't like this sheet. Okay, so if you've got x squared is 4ay, vertex 0, 0, girls, what's the focus? 0. Anyone? What's the focal length? A. That's the focus, 0A. What's the directrix? X is minus A. It's just what we were doing before. Okay, you know this. You've done this before. Sorry, that's y equals minus A, by the way. So the directrix is y equals minus A. Okay? Again, any point on the parabola is 2AT, AT squared. But girls, sometimes they just don't do 2AT, AT squared. Sometimes they might do 2AP, AP squared. That might be point P. Do you know what I mean? This I would call point T on the parabola, 2AT, AT squared. If I want point P on the parabola, I might say 2AP, AP squared. If I want point Q on the parabola, I would call it 2AQ, AQ squared. Does that make sense? If you're talking about point R on the parabola, call it 2AR, AR squared. Does that make sense? But with smaller letters. You okay? Or not? So girls, what you're going to see, what we're going to be doing from now on, we're going to be using P and Q a lot. The general form of point T is 2AT, AT squared. If you want to talk about point P, it would be 2A little p, AP squared, just replacing the T's with P's. If you're talking about point Q on a parabola, you'd call it 2AQ, AQ squared. Do you get the idea? As long as it's in that format, 2AT, AT squared. That's for point T. For point P, 2AP, AP squared. Point Q, 2AQ, AQ squared. So I'll just show you what I mean by that. Now, just watch. You know how the general point, say point T, is 2AT, AT squared, yeah? If I've got point P, I'll call it 2AP, AP squared. It's in that format. Do you get the idea? If I've got point Q, I'll call it 2AQ, AQ squared. Do you get the idea? Yes or no? As long as they're all in the format of 2AT, AT squared. Got the idea? So all we've learned is x squared is 4ay, and the parameters are 2AT, AT squared, but that's if it was point T. If it was point P, it'd be 2AP, AP squared. Point Q, 2AQ, AQ squared. Got the idea? All right. Now, let's just look back over here. I'm not worried about that. Okay. All right. Someone might ask you in example 3 to find the parametric equations for the parabola x squared is minus 12y. Okay. When I look at that, x squared is minus 12y, what would you normally have done? You'd say x squared is minus 12y is of the type x squared is minus 4ay. So therefore, what's a? Oh, they've got negative 3, and that is, oh, yeah. Yes. Now, yes. Remember how I told you that all our parabolas will be dealing with our x squared is 4ay type? So if you're going to use that, you've got to call it an x squared is minus 4ay type. You either call it an x squared is minus 4ay type. Do you know what I'm saying? Look, I think we're best off flipping it around. What do you reckon? We've got to be very careful here, actually. We've got to be really careful. No. All right. So, girls, we're going to look at the 4 types of parabolas. We will look at sideways ones. They do them in your book. The first type is x squared is 4ay. It's concave up parabola with vertex 0, 0. Tell me what the focus is, or the focal length. Focal length is A. What's the focus? 0A. Got it? What, you know where the directrix is? Down there. All right? Parameters would be x is 2AT, y is AT squared, yeah? We're going to look at the next type. We're going to do the 4 types. X squared. So what you do is you sketch them. X squared is minus 4ay type. Looks like this, yeah? All right. Girls, notice with this first one, x values are always across. You're going to tell me, miss, those x values are sometimes positive or negative. Girls, they are. It just depends on the value of t that we have. If t is 0, T could be 1 or it could be 2 or... Do you know what I mean?
Like that, the same with the shifted.
Yeah. Yeah, but just not shifted off the centre, but only 0, 0. We're just doing the 4 basics. So x squared is 4ay, is x is 2at, y is at squared, because always the y values will be positive up here. This type, the point T, the parameters are, again, the x one's the same, x is 2at, but the y one's different. Now, what's the y one? Minus at squared, because this point T here could be 2at minus at squared. Can you see that the y value here is always negative? Look, the x values come across here, but the y values are always negative. They're always underneath the x-axis. So they're the parametric equations for the parabola. X squared is minus 4ay. 2at, at squared is for the normal parabola, x squared is 4ay. Are we okay with this? Then we're going to do the sideway ones. Oh, what I'll do, I'll prove that. Proof. All right.
Are you going to prove the first one as well?
Yeah, I might prove the first one as well. All right, let's go back over. Are we okay? So x is 2... No, it's just substituting. It's not even a proof. So x is 2at, right? T is the, so if you've got that, x is 2at, y is minus at squared, we want to show that we actually get that parabola up there, that's all. So not proof, writing the, basically I'm going from parametric equation to Cartesian. So if x is 2at, what's t? X on 2a. I'm going to sub into y is negative at squared. And what do I get? Y is negative a x over 2a squared. Next time I won't go through those sheets. It's better if I write. Y is negative a. What do I get now? X. So girls, we're saying that the parametrics for a concave down parabola vertex 0, 0 is 2at minus at squared. We're going to go from the parametric equations and form the Cartesian to show that this is the case. So we've got x is 2at, y is minus at squared, making t the subject. T is x on 2a. Substitute t is x on 2a into that, and we get y is negative a times x on 2a. All of that's got to be squared, and what do you get? X squared over 4a squared. Cancelling the a's, one of the a's, what do you get? Minus x squared over, and then moving the 4a to the other side, you get 4ay is minus x squared, but we don't like writing it like that. Let's take the negative. In other words, x squared is minus 4ay, swapping sides. Do you know what I mean? Taking the negative x squared over there and the 4ay over there, you've got negative x squared is negative 4ay. All right, I'll do the same with the first one, even though we've done it before. You okay with that now? So the concave down one is 2at minus at squared. You got all that? Let's just do it here. X is 2at, y is at squared. Let's rearrange t, and what do you get? T is x on 2a, sub that into y is at squared. You can call them equation 1 and 2. And you get y is what? A x on 2a squared. A. Make sure you square the 2 and the a, and you get 4a squared. What can you cancel? X squared on 4a. So what do you get? Yeah, so 4ay is x squared, or x squared is 4ay. Yeah? Let's look at the sideway ones. I said we wouldn't do them, but they seem to do them there, so we'll do them. You got that, girls? So I think I've gone around the world here today. This type, be careful. Now, I'll just call my parameter. You've got to do, for that type, the x's and the y's. You know how this parabola is x squared is 4ay? and this one is y squared is 4ax. It seems that the x's and the y's were switched around. You know how normally we see x squared is 4ay? But the sideway parabola, you know, is y squared is 4ax. So the x's and the y's have been switched. You have to switch the x's and the y's. So instead of 2at squared, I want to see at squared 2at. All right, let's prove that if the parameters are, so in other words, the parameters are x is at squared, y is 2at. If they are indeed the parameters, and I write the Cartesian equation of those two parametric equations, I should end up with y squared is 4ax. So let's start. X is at squared, y is 2at. Which one do you think I should rearrange? Because I do not want the square root with the x ones. So let's rearrange the y equation and get that t is what?
Y on 2a.
Yep, and we're going to substitute t is y on 2a into x squared is at squared. Do you see why we're doing that? Imagine making t the subject of this one. You'll get t squared is x on a. T is the square root of x on the square root of a, and it's going to end up a big mess. So it's best to, yes, I've got these two parametric equations because that's what we think they are. Girls, always make t the subject for the one that's easier to make t the subject with, and it's easier in this one this time. T is y on 2a. Put that into there, and what do you get? X squared is a times y over 2a squared. So x squared, I think I've done, no, it's not x squared, it's x. Girls, I've written that wrong. Why don't you pick me up? I'm substituting it into x is at squared, not x squared. I'm just got x squareds in my brain. It's into x is at squared, aren't I? That's the equation. Sorry, I'm just stuck on x squared is 4ay. So substitute t is y on 2a into x equals at squared, and we get x is a times that squared. What do you get? Y squared on 4a squared. So x is y squared on 4a, and then y squared is 4ax. So it is that type. So therefore these are the parameters of y squared is 4ax. We've sort of guessed what the parameters are, and now we're just checking that when we change these two parametric equations into the Cartesian, they're the parametrics, this is the Cartesian. They're the parametric equations with the third parameter. Get the idea? They're the parametric equations. Let's just check that they are by doing this. Yes, we do end up with that Cartesian equation. Y squared is 4ax. Did you get that? Now I'm going to do the same with the last type. What do you think we're going to do? Y squared is minus 4ax. This way. Yep. Can I move? All right, let's do what we think is the last type. Get rid of that. Sorry about that. I should never have done that page. It's so messy, but it doesn't matter. Y squared is minus 4ax. Now tell me what you got to do. Instead of 2at, at squared, you've got to do the at squared first. Can I have some tapey stuff, please? Yeah. Now look at the x. Oh, sorry, girls. Actually, yes, you're right. It is negative. Because why? Look at the x values. Aren't they always negative? Can you see that? Look, x is negative. X is always negative. Now, you know how the other one up here, just coming up here for a sec, you know how this was 2at minus at squared? We've got to swap them. Minus at squared 2at. Do you get it? This bottom one here is the reverse of the concave down type of the other. So x is minus at squared, y is 2at. That? No. No, the y values are sometimes positive or negative. No, all right. If you remember that type, x is 2at, y is at squared, and swap them for the sideway one. 2at minus at squared, for the sideway one it's minus at squared 2at. Got it?
Yeah.
But look, you can tell, look, the y values here are sometimes positive, sometimes negative. Look, if you were to read the points, this might be -3, +5, -3, -5. So the y values are positive and negative, but the x values are always negative. All right. The reason you've got to have the negative here is because sometimes you're squaring the t. That's always positive when you square the t, no matter what it is. T squared is always positive. A is always positive because it's a focal length. All the x values here are negative. You need a negative in front. So if we've got x is -at squared, y is 2at, which one do I rearrange? The easier one, with just the normal t in it. And what do you get? T is y on 2a. I'm going to sub that into x is minus at squared. What do I get? Minus a. So I'm going to sub t is y on 2a into x is minus at squared. What do I get? Do you know what I'm doing? Do you know what I'm doing, girls? I'm taking the two parametrics, making t the subject of the easier one, and substituting it back in. That way we eliminate t. So what do I get? X is minus a. What do I get? So x is, one of the a's cancels from the top and the bottom, -y squared over 4a. 4ax is -y squared. Swapping sides, y squared is minus 4ax. Please get these parameters down properly. Now look, let me tell you, you're only going to get the concave up type. This first exercise, they'll do some of all types, but in the HSC, you just get the concave up type. And they give you the parameters. All right? So we're keeping focal length positive all the time because that's what it's meant to be. So ignore that sheet. They made a negative focal length and we don't want to do that. So we're going from parametric to Cartesian equation there. Why don't we just look at some examples? Do you want me to just do some examples?
Yeah, okay.
All right, I think... Okay, girls, have you finished that? Done? All right, just some examples from your book. 11.8, equation of these parabolas. Here, I'll do question 2b. X is t plus 3, y is 2t minus 5. Shh. Find the Cartesian equation of those parametric ones. Now, they're obviously not in the format that we're used to seeing, but you know the format, you know the way you would do it. The Cartesian equation, I want the yx equation with no t's in it. You take the easiest one, I'll call that equation 1 and 2. Which one do you rearrange? Yeah, you arrange the first one. So t is what? X. And just sub that in equation 2. And you get y is 2, bracket, here's the t. So I've rearranged the first equation to make t the subject, and then I'm substituting it into equation 2. So when I hit the t, I'll replace it with?
X minus 3.
And I get 2x minus 6 minus 5. In other words, the Cartesian equation is y equals 2x minus 11. That one's easy. That's okay. Question 2e. X is 1 on t, equation 1. Y is 2t, equation 2. I don't mind which one you rearrange, but I'd probably be rearranging number 1. Don't you swap them diagonally? So rearranging 1, what do you get? T is 1 on x. And then we're going to sub that. So girls, we've rearranged 1, just swapping the t and the x, sub in equation 2, and you get y is 2 times t. In other words, y is 2 on x. It's a hyperbola. So these are the Cartesian equations of a hyperbola. Shh. Now, I'm going to go to your sheet. 1 minute. All right, I need room. The other handout. The Cambridge one, the 9D. So this is worksheet 9D. Oh yeah, they're there. 3 minus t. What do we do? Oh. Question C. No. Oh, for the first bit, like Cartesian equation could be any types of equations. Worksheet 9D, question 5C. Find the Cartesian equation of this curve. X is t plus 1 on t. You're not going to like this one. Y is t squared plus 1 on t squared. Okay, this one, we're going to use a different approach. What do you think about the relationship between that t plus 1 on t and that t squared plus 1 on t squared? What does it make? What? Yeah, but with a bit of something else. So let's just work out what x squared is, huh? What it is, y is x squared, but it's either going to be plus or minus something. Minus something. All right, I'm going to work out x squared. Let me just work out x squared. Girls, to square x, you got to square all of it. No, nearly. Let's just look, we're thinking y is some form of x squared combined somehow, right? Let's just work out what x squared is. And what do you get? T squared plus 2 times t times 1 on t plus 1 on t squared. Now, what is 2 times t times 1 on t? Yeah, so it's t squared plus, can I add this 1 on t squared first, plus 2. That's what that is. Now, y squared, isn't it t squared plus, so you know what I'm going to do? I'm just going to write that, I'm going to make this look like that. X squared minus 2 is t squared plus 1 on t squared. How do you feel about that? Do you know why I did that? Because you're squaring 1 and t. Girls, wait. I've swapped. No, stop. I did t squared plus 1 on t squared. Do you understand that? Plus 2. Now, what I've done, girls, because y equals t squared plus 1 on t squared, I thought I'd take this plus 2 to the other side. What can I replace this t squared plus 1 on t squared with? So x squared minus 2 is y. Yeah, so y is x squared minus 2. I would like to do one more. I need a paper. That was from your worksheet. Girls, there's going to be a homework video. I'm nowhere near finished. Do you want me to do one more here? I can do it on video. What I'm going to do on video, I'm going to do a few more examples from 11.8 and a few examples from 9D, and then set you a few questions for homework. Got it? I don't know when I'm going to do it because I've got to run somewhere after school. Oops, don't want to record that.